welcome back to my channel. In today's video, we'll be solving a problem from LeetCode which says a combination and it's question number 77, right? So, what basically combination says is like, first let us check the problem statement. So, this problem statement is we are given with two integers, either n or and k, and what k is basically it will return all possible combinations of k numbers, and that will be in the range from 1 to n, and we can return the answer in any order. Order is not uh, it is not a case of concern in this problem statement. We can return it in any order. So we'll check the first example. What the first example says is input n equals to k 4 and k equals to 2. So let us just show this to you. Like we are given what n equals to 4 and k equals to 2. So basically 4, this is n, and what our k is given to us? K is a 2, right? So what we are having is for n equals to 4, we are having 1, 2 and 3 and 4. So these are the elements that we are having. Now for making the combination, what we can do is we can make combination like the number of elements or the size of the combination that we can make will be like at most of k equals to 2. So for that we can have either 1, 2, let me show you, like we can have either 1 2, or we can have 1 3, or we can have 1 4, or what we can have 2 3, we can have 2 4, we can have 4 3, right? But what we cannot have is, while we are having 1 2, we cannot have 2 1. This is not possible because you can check it here. It was mentioned that 1 2 and 2 1 are considered to be the same conditions. So 1 2 and 2 1 cannot be added. If 1 2 is added, 2 1 cannot be added. Clear? And what we cannot add is, like we cannot add 1 1 or 2 2. Like two identical elements cannot be added. These things are also not possible. So what we can add is, we can add 1 2 1 3 1 4 2 3 2 4 3 4. These things we can add. So basically, how we can solve this problem? We can solve this problem by using backtracking. The like famous approach to solve this kind of combination problem is using backtracking. So now we'll check how we can solve this using backtracking. So this is the thing that is given to us. We are provided with n equals to 4 and k equals to 2, right? And now what we'll do? We'll go for the first element. We are having, let us assume we are having two dashes. We'll go for the first element. In the first dash, we're going to put is 1. Now we'll go down, and we are having one more dash to be fulfilled, and for that we have three options. We are having 1 2, 1 3 and 1 4. We can choose for any of them. So for my convenience, the first one I am choosing is 1 2. You can have 1 3 also, that like which one you want to use, we can use, like no issues. But for the simplicity of the code, what we will do, we'll just go for the first one, that is 1 2. So what we are having is 1 2, and we are saying that the size of this combination matches with the size of k's value. So we will just include this one in a final, I would say the final array list that will be created. So let us think that this is our final array list. uh, this is our final array list. Okay, so what we will do, first element we will put here is 1 2, right? Now we will simply backtrack from its place because we need to search for other elements too. So what we'll do now, we'll remove the lastly added element, and again we are where we are at 1 dash. Now I have two more options, 1 3 or 1 4. I'll go for 1 3. So in this position we are putting 3, and we are saying that this is also matching the condition of case value. So we'll just again put this one in this position. 1 3 is also been added. Again we will backtrack from its place. We'll go and remove 3 from its place. We'll remove 3, and what I need to put, remaining element, what is remain to be put at like 1 3 1 4. Now we'll go for 1 4. We'll see that this is also satisfying the condition and no more elements like 4 1. So we'll again put this one in our array list. So these are the combinations that are happening, right? We'll go back from its place. Now we'll remove 4. We'll see like every possible combinations with 1 has been done. We'll remove 1. We'll go to the initial place. We are again left with 2 empty dashes. So in the first place, what you're going to put is 2 because 1 is completed. Now we are going with 2. We have put in 2 and going down. Again, after 2, we have one more space to be added. We are going down for 2, 1. Now what we are seeing in this list, we already have 1, 2. So 2, 1 is not possible. We will go back. We'll search for the other possible cases. We'll go for 2, 3 and see that 3, 2 is not added here and it is also matching this side. So this can be added. So what we are adding here is 2, 3. Now what we are doing, we are again backtracking and removing 3 from its place. So this is again an empty one. And what more we can add is 2, 4. We will go down and see that 2, 4 can also be added. So we'll add 2, 4 in this place. Excuse my writing. And yeah, it's 4. I guess it's understandable. Yeah, it's 4. So we can add 2, 4 in this place and again we can simply backtrack, and now we'll see like all the possible cases with 2 has been fulfilled and we can remove 2 from its place. We are again go back to the initial place and we are again left with 2 empty dashes. In the first place, now we're gonna put 3, and with 3 we're gonna go down and we are having one place to be like fulfilled, and we will go down. And basically why it's written 3, 4, I will show you. Like what we're gonna do is we're gonna search for 3, 1 also, and we're gonna search for 3, 2 also. Okay, so while adding 3, 1, what we'll see in this list, 1, 3 was already previously added, and for 3, 2 we'll see 2, 3 was previously added. So we will simply backtrack from them and we'll go down and see like only 3, 4 was not previously added. So what we're gonna do is we're gonna add 3, 4 here. Clear? After adding 3, 4, we will simply backtrack from its place. We will search for more combinations with 3. We'll see that no more combinations are possible. So we will remove 3 also from its place and we will be again left with 2 dashes. So basically in the first dash, what you're going to put is, because 3 has also been done, we're going to put 4 and we'll check for other more possible cases. So we are going down with 4. We are seeing that with 4 we can add 4, 1. We can add 4, 2. We can add 4, 3. But what we'll see while adding 4, 1, 1, 4 was previously added, so cancelled out. We'll see 2, 4 was previously added, cancelled out. We'll see like 3, 4 was previously added, so this one is also cancelled out. We'll simply backtrack from each of them and simply remove 4 also from it, and furthermore we'll see that no more elements are there to be searched for, no more combinations can be happen. So we'll simply return and in the final array list this will be returned, like this will be our final combinations that will be possible, right? This will be the result. So now the question comes, how we can solve this, like how we can check for the previously loaded elements. We'll go to each one of them and check that it's matching or not. No, there's an optimal method to solve it. So what we are having here is we are having 1, 2, 3 and 4. So this is the most important trick you need to remember. Do not forget this part. So while we are putting 1 in the our combination, when we are putting 1 with 1, what are the possible combinations we can put is 1, 2 and 3. Clear to all? So that's done, right? So when we are going for 2, we will not look back to 1. We will only look forward. We will look for only 3 and 4. We will not look backward. If we look backward, there will be that chance of having duplicate elements. We will not look backward. This scenario will never happen, okay? We will only look for the forward elements. While at 1, we will look for 2, 3, 4. While at 2, we will look for 3, 4. While at 3, we will look for, see, only 4. And while at 4, there's no more element, we will simply return, right? This is the like optimal way how we can solve this problem. We'll just only look at the forward elements. That means we'll need an integer which will store the location of the present element and which will help us to like increase that element and will not look back. This is the way to solve this problem. Now we'll go to the code. I will be using Java to solve this problem. You can use any other programming language as you want. Java feels a bit like easier for me to solve. So I'll be using Java. And if you want like this combination problem is exactly similar to the problem that we have done for permutation. They are exactly similar. Okay. So the thing is, if you want to solve this combination problem, firstly you need to learn about permutation. So if you want to check permutation, it's been already uploaded in my channel previously. You can go in the playlist of LeetCode problems. You can check that problem of permutation too. Now I'll be solving for combination A. Same. What it is returning is list of integers. Why it's list of integers? Because combination that we are returning itself is a list, right? So basically we are returning a list of integers. So what we'll be returning here is list of integers. Let us name that as result or anything as we wish, and then we will simply array list. Done, right? Now we'll simply return this result. Completed. Now what we're gonna do is we need a backtrack function that will basically keep a track of this entire thing. So what I need is backtrack. Here what we're gonna send is result. We're gonna send n, we're gonna send k, and what we're gonna send is c. We will send the position of the element where we are currently located. So we are starting with 1. So I'm gonna send here 1. So this will be the tracking element, right? So I'm gonna send this as 1 with the start value. Now what we send is a freshly created array list. We will send this because while you're checking, see here, wait a second. Why we need this new array list is, see here, 1 2 1 3 or 1 2 1 3 1 4 2 3 2 4, like all of them are list, right? And we are storing them in a list. So while creating this small list we need an array list. So basically this array list is nothing but that small lists inside that, right? So this backtrack function basically returns nothing, so it's void. Done. So what we can do now is backtrack, and inside that what you're gonna put is this list of integers result. Now we're gonna put is int n, we're gonna put in k, and int start for that tracking element. Remember? And now what you're gonna do is list of integer for that combination integer list, and you're gonna name that as com. Clear? Now what we're gonna do is we'll firstly write the base case. What is the best case? If the size of combination matches with the size of k, we will simply add that one to our final result. Means if the size of this matches with the size of this, we will add that to here. We're gonna do that. How we're gonna do that is if com dot size equals to what? K. What we're gonna do is we're gonna add that where result dot add, we will add that to our result, right? So what you're gonna add to our result is our combination. We will add com to our result. Added, and now we will simply return from here. Now we need to like change from 1 to 2, 2 to 3. For that what we need an for loop. We're gonna implement for loop here. And I equals to 0. Sorry, we'll not start from 0. From where we'll start? We will start from a start element. And what is the value of start? It's automatically initialized. It's 1. So from where you're going to start? You're going to start from start and till where we'll go, value is less than equals to n and I plus plus. Then what you're gonna do is we will add that element to our comb. What we'll add? We'll add I. Now what we're gonna do is we will call this backtrack function. We'll give res, we'll give n, we'll give k, and now if we are at 1, sorry, see, if we are at 1, we have to go to 2 for the next case. So basically it's if we are at I, where we go, um, it's not working out. See, if we are at basically I, what where we need to go next is I plus 1, right? Then only we can, if think this is our I and think we have to go to 2. So what basically we need to do? We need to go from I to I plus 1. That is what we need to do. Right. So here where we need to go is from I to I plus 1. We need to return I plus 1, and of course our new mate come done. And now we need to like remove the last added element. To remove the last added element after backtracking, what you need to do, com dot remove. And how we gonna get the last element? Com dot size will give the size of the element, and minus that will minus 1 will give the uh, position of the last element. So you got the position of the last element, and that's all for this code. It's a very simple 18-line code. Clear? I will just run it and check if any issue is there. If there any issue, we will solve. So no issues are present, and we'll submit this code. So yeah, this code is running absolutely fine. That's all for today's code. And if you are having any optimal solution, just comment it down, and I will check it if you are have with any more optimal solutions. And yeah, if you like this video, don't forget to hit a like and subscribe to my channel. In the next session, we'll be learning about one of the most favorite interviewers question, that is rat in a maze, and that will also be solved using backtracking, and it is like real interesting question. So stay tuned for that session, and that's all for today. Thank you.